Oh. Okay. So this is for exam 1 review. I will also post these notes on Canvas. Math 242. Exam 1. Exam 1 will be no calculator, but you really won't need any. No cheat sheet. Okay. So let's begin with chapter 1 first. Let's make sure we understand all concepts and what you can expect. You will have 50 minutes during lecture time, so it will not be too long. It will be 6 or 7 problems, not that bad. Okay. This is chapter 1. So all the things to know from chapter 1. Of course, you should read my lecture notes to prepare. And every example in my lecture notes, in the take-home quiz or the quizzes that I gave you in class, is relevant. So read lecture notes. Like that's nothing will be outside of my lecture notes, quizzes, written homework. Okay, well, the first concept is a question that you can expect in exam is finding the number of solutions. So question number 1 will be find how many solutions a system will have. How many solutions a system of linear equations will have. Linear equations. Now, the typical problem will involve a matrix in augmented form. For example, suppose I give you, let's just say I give you this matrix. I have 1, 0, 3, 4, 5, and I have say 7 here, and then I have 0, 0, 1, 2, 3, 5, and then I have 0, 0, 0, 0, 4, 2, 0, 0, 0, 0, 0, 0. Okay. Now it will be, you'll notice in exam, matrices will be almost row reduced, like this one. All you have to do here is just make this 4 or 1 by dividing this row. Otherwise, it's almost in REF, right? So you will not be required to do much work here. I want you to find how many solutions this matrix will have. This is a system of linear equations. How many solutions? What are the concepts that you need to remember? What did you say? Infinitely? Yes, exactly. What did you recall? Recall, if your number of variables, I'll come back to this question. I want you to memorize this. If your number of variables are more than number of non-zero rows, then we definitely have infinitely many solutions, right? That's the first thing. And non-zero rows in your REF. So you should not be doing any math here. This is almost in REF. So you can check the number of non-zero rows is 3. And how many variables here? How many go with 5? So how many solutions will this system have? Everybody can answer this question? Okay, can you do this in exam? So here, number of variables is 5, and number of non-zero rows, non-zero question? Yes. Yeah. It's just It's a free variable, right? You just count the rows. Non-zero rows is 3. So which is greater than that, right? So this system will have infinitely many solutions. Good. And you just box your final answer. Okay, well, that was case 1. You will see that sometimes the matrices will be reduced. And case 2, you will notice that the number of variables will be exactly equal to the number of non-zero rows. Non-zero rows in REF. What happens then? Then we have a unique solution, exactly 1. We have a unique solution. Good. Okay, so there could be many rows, but if all of them are 0 and you only have 2 non-zero rows for 2 variables, you still have unique solution. Now we have to be careful for the third part, because sometimes you do end up with a non-zero row, but it will look like this. So what happens if you end up with a row like this? There are zeros everywhere, but the augmented part is non-zero. It's not no solution. It's no solution. Then we say no solution. Now this row could be anywhere in your matrix. As long as you see it, don't even bother. No solution. Okay? No need to row reduce, no need to do anything. Question. Which one? Oh, I'm just saying this will be a non-zero entry. It could be a non-zero number. Okay? Yeah. Just remember this. Okay, I'll post this. Now, once you know, you can look at a matrix, you can count the variables, you can count the non-zero rows, and you can tell how many solutions. Question number 2. Any questions? Everybody can do this on the exam? Okay, good. Question number 2 will be, how do I figure out your free variables? Now, what was the technique I taught you in class? Raise hand if you know. I taught you 2 methods. One was just looking at the matrix, and one was converting it back to system of equations. Do you know both methods? Well, that you have to reduce it, but how do you tell which ones are free? Raise hand if you know. You should remember this. Okay, just one. Yeah, I see him. Okay, yes. What's the answer? Oh, great job. What's your name? Ian, exactly. You rewrite the system. This is method 1. There are many methods, okay? Method 1. You'll rewrite. Oh God, what is happening here? Sorry, hold on. Rewrite the REF, the reduced matrix as system of equations again. System of equations. So if your variable does not have coefficient 1, then it is free. By free, I mean then that variable will be a parameter. You introduce a parameter, you set that variable equal to t or s or r, stuff like that. What was the second way? Method 2. Look at the matrix. Method 2 was look at the matrix and look at the REF matrix and notice. I will post these notes, so don't worry about writing too much. Just make sure you understand what I'm saying here. Notice the staircase pivots. The staircase pivots, right? So let's go back to this one for an example. Okay, I want to go staircase, so I begin from top left. Second one doesn't have it, right? So my x2 doesn't get one. The next pivot happens at x3. Then 4 doesn't have one. The next pivot happens at x5. You see, we only go down if I have a non-zero entry. So which of the columns have a pivot? x1, x3, and x5, right? They are the only ones following the staircase. So which ones are free? x2 and x4. Okay, who wants me to explain this again? Raise hand if you want me to explain this again. Okay, look at this one. You begin from the top left. Okay, you keep going left unless you see a non-zero entry. There is no non-zero entry, so keep going. Oh, there you see. So I can go down here, right? Now keep going. I don't see a non-zero entry here, right? Oh, there you go. Then I go down. So that's the staircase pattern. But you see, I had to skip a few because they didn't have a non-zero entry. So wherever you go down, wherever the staircase pattern follows, those columns have the pivot, right? So the free variables are the ones that do not have the pivot. So only x1 got a pivot, x3 got a pivot, x5 got a pivot. So in this question, in the above example, your free variables are x2 and x4. And you could also check when you would rewrite the equations, x2 and x4 will be the only variables without the coefficient 1. But that, I want to give you one more example. Okay, what about this one? Example number 2. Same thing. I want you to, question is the same. Question number, we're still in chapter 1. Find how many solutions? Find how many solutions? Well, that's the first thing. And if you have infinitely many solutions, then you have to parameterize them. Now, if you recall, I've been giving you homework from exam reviews, right? For the past exam. So you see this question is repeated in every exam. This is important. So let's say I give you this matrix. 1, 0, 3, 1, and I get, say, 2, and I got 0, 0, 1, 1, I get -1, and I get 0, 0, 0, 1, and I get 3 here, and I get 0, 0, 0, 0, 0. Okay? First things first, how many variables? Good job. Number of variables equals 4. Good. How many non-zero rows? Non-zero rows equals 3. Good job, right? Because you cannot make this one a 0 because that will also change, right? So you have non-zero rows 3. Which ones are your free variable? Actually, wait a minute. How many free variables? How did you get there? Yeah, this is the formula to use. You take number of variables, subtract number of non-zero rows. Okay. So what do you get here? Well, let's just start the staircase pattern. So I have a pivot here. I have to continue going. Oh, I see a pivot here, right? I have to continue going. I see a pivot here. There you go. Which columns got the pivot? 1, 3, and 4. But I want you to parameterize the answer. I want you to find me a general solution. In this case, you have no choice. You have to write down the system of equations again. So write down the system of equations. What do you get? So I have x1 plus 3x3 plus x4 equals 2, right? x3 plus x4, so far good, equals -1. x4 equals 3, right? The method of looking for the variable which has a non-1 coefficient would not work here. So you have to make sure that you know which one is free. I know that x2 is free. Let's call that guy a t. Good. x2 becomes t. What do you get? Write everything in terms of the variable. Well, in this case, that was a weird question. You still need to parameterize because x2 is not dependent on anything. But I didn't pick a good example. Okay, let's just simplify. What do you get? x1 is 2 minus 3 times x3. Yeah, who's going to simplify this for me? How many agree? Agree with the Wyatt? So x4 is 3 for sure. Plug in here. x3 is -4. And x4 will be 2 plus 12 minus 3. So 14 minus 3 is 11. Okay, I'm getting different answers. Okay, so see, you don't need a calculator for this. But we still need to introduce the parameter because how do you write the general solution? General solution will be, well, what is your x1? So that's 11. x2 is the free variable. x3 is the -4. x4 is 3. Yeah, it will never look this nice. But this is just to explain. Read more examples in my lecture notes where I have 1 or 2 variables and everything else can be expressed in terms of variables. Can you do this question in exam? Okay, what am I missing? The parameter belongs to real numbers, right? I have to make sure I have included everything, right? The solution set. Good.
Question for the other part, where it's the three variables. So the three variables, like the matrix above. This one. Yeah, that one. Why why can't x2 and x3 be the three variables and then x4 is like not a two variable?
Oh, because x3 has a pivot, and even if you try to push it and make x3 a free variable, it will not be a wrong answer, but the math will be too complicated. So we always pick, see, this one has a 1, this one has a 1, this can be a 1, right? These will be nicer. You can express x1 in terms of other variables easily. That's why we pick those. Okay, but won't be technically incorrect, but stick to the system. Good. Okay, so I did not pick, I picked a really easy example for you guys, but you see the pattern here, right? Everybody can do this in the exam. Okay, this takes care of chapter 1. This is all I wanted to know from chapter 1. Oh, I have one more thing. For example 1 above, if I ask you to find me the solution set for example 1, in case you want to check your answer, solution set, for example, 1 above, because there I have two free variables, right? X2 is, let's just call X2 to be S and X4 to be T. So when you write each other variable in terms of the free variable, you will get something like this. So your X1 will be 2T negative 6, X2 will be S, X3 will be 7 over 2 minus 2T, X4 will be T, X5 will be half. So maybe just practice this. This looks more like it, of something that you can get in exam. Belongs to R. This is a solution set. Solution set. Good. As long as you can turn your reduced matrix into a system of equations and figure out your free variables and express every other variable in terms of the parameters, you should be good. Okay. Okay, let's move on to chapter 2. So chapter 2 was all about matrices. Again, read lecture notes. I have a bunch of theorems about, just know two things are important: finding A inverse and multiplication of matrices. Just don't forget these two. Videos for everything are on my channel, so just make sure you practice. If you're stuck, watch a video, and make sure you write the questions down. From past experience, you think this course is very easy. You read through a question and you're like, yeah, I can handle it. And when you have to write down the solution, you get stuck. Don't do that. Write down the solutions. Pick a matrix, start row reducing it. Pick a matrix, find its inverse. Solve a system, write down the parameters, multiply a matrix, and check your answers. Do the work on paper, okay? Don't just read through lecture notes, okay? Now, what is the one thing that I want you to know about chapter 2 is, well, first, finding inverses. Finding inverses using Gauss-Jordan elimination, right? So question will be very typical. I give you a matrix A. I have 3, 2, 1 for my example. 1, 3, 1. And I ask you find A inverse using the elimination method. What do? What's the first step? Augment it with identity, right? That's the first thing you'll do. Augment the matrix with identity. Okay, and then you start to row reduce. And if you can get to the identity, that means the other side is the, okay, everybody can do this. Now I have plenty of examples solved in my lecture notes. So I believe in you. You can row reduce this. And after 1, 2, 3, 4, 5, 6, after 6 row operations, now I have to cover more things. After 6 row operations, that's one way to check. You will end up with this matrix: 0, 0, 0, 1, 0, 0, 0, 1. So I end up with identity. So if I can row reduce the A to get to identity, then the matrix on the other side is my inverse. So in this case, my inverse will be 7 over 16, 1 over 16, negative. Each term will be divided by 16 for some reason. 2 over 16, and yeah, brush up on your what do you call it, fraction skills. How to add a fraction, how to multiply a fraction, how to divide a fraction. Do you want me to refresh that? Oh, you're all engineers, you should know. How many want me to go over the basics of fractions? Well, you could take the 1/16 out, and the A inverse would be just, you could write it like this. A inverse would be 1/16 times the whole matrix. Yes.
Would that be the exponent?
Yes. If I ask you to find the A inverse, this is the answer. This is perfectly fine. Good? Yes. You can combine steps. Yeah. Just like I do during lectures, combine steps. Yeah. Good. As long as you're comfortable. Don't combine steps if you're not comfortable. Okay, practice this. And the next question, which is very important from chapter 2, will be solve a system of linear equation. Solve a system of linear equations using matrix inverses. So you know how we always solved a system of linear equations using Gauss-Jordan? Well, I will ask you to solve a system using matrix inverse. So suppose I'm giving you a system like this. Let's just pick this one. I have 3x1 plus 2x2 plus x3 equals 7. Then I have x2 negative x3 equals 6. Then I have x1 plus 3x2 plus x3 equals 4. Well, part 1, can you express this system as a matrix product? Can you do that? As a product of matrices. Order matters. What is your A? Yeah, A is just the, everybody can do this? Are you writing the answers on your notebook? Okay, so A will be 3, 2, 1, 0, 1, negative 1, 1, 3, 1. And what is your X? X1, X2, X3, right? What is B? And how do I write it as a equation? So I get 3, 2, 1, 0, 1, negative 1. Yeah, 1, 3, 1 times X, which is that matrix. And it makes sense, right? This is 3 by 3. This is 3 by 1. When I multiply, I should get a 3 by 1 matrix, right? So this is just writing a system as a matrix product. Okay, now how do I use the inverse of A to solve for X? I did ask you this question in the quiz, and all of you, most of you could not answer. Yeah, now you're raising your hand. Good job, yes.
Multiply it on both sides.
No, A inverse, so order matters, right? You're multiplying by A inverse on the left. So then question will be use A inverse, not Gauss-Jordan elimination, to solve for X. So what will you do? You will multiply, because this was your equation, right? Multiply both sides by A inverse. But be careful, it goes on the left. If you have the wrong order, I will not give you any grade. Because you can only multiply it from the left, otherwise the product is not defined. So X will be A inverse. A was this matrix, 0, 1, negative 1, 1, 3, 1. Not A, its inverse times B. And we just found the inverse for this matrix. The previous question, yes. No, if I ask you to use A inverse, then A must be invertible to apply the rule. Otherwise, you have to do Gauss-Jordan. Okay, what was A inverse? I just found it here. No, it's the same one. Okay, let's fix it. I'm not going to find the inverse again. Okay, so we're just going to use this matrix, okay? Well, that was my intention, to use the same matrix, because I want to emphasize in exams, sometimes you might not even have to find the inverse. It will be given to you. Make sure you pick the right matrix, okay? Sometimes the inverse will be there. You just have to look for it. So now I just found the inverse, right? So I can just multiply the matrix. Okay, let's just copy that down. 1 over 16. The inverse was 7, 1, -5, -2, -14, 6, -1, -7, 3, multiplied by 7, 6, 4. Okay, now that's why you need to know how to multiply matrices. This is 3 by 3, this is 3 by 1. How many can solve this? All of you should be able to solve this, okay? Or by Tuesday at least. Okay, good. So what will I do? I multiply row 1 with column 1. So I get 49 plus 6 minus 20. Row 2 with column 1, I get -14, -84 plus 24. Row 3, column 1, I get -7, -42 plus 12. So what do I get? Well, just you can do this math, right?
40, 36.
Where do you see 36? Find a mistake. 29 plus 6 will be 35, and I get -98. Oh, well, I just get plus 10, get -74. So I get -30, -37. Okay? I mean, math could be wrong, but you get the idea of it, right? Can you solve a system of linear equations using matrices? Can you do it in exam? Who wants me to explain again? Okay, good. Oh, you want to, which part? Which step? This one? So I'm just multiplying two matrices. Watch a video on multiplying matrices. What do I do? Write down the system. You'll have a 3 by 1. You'll multiply row 1 with column 1. There's only one column. Row 2 with column 1 and add row 3 with column 1 and then add everything up. So row 1, multiply entry wise 7 times 7, 1 times 6, and then add. So practice, okay? Don't read through matrix multiplication. Try to solve as many problems as you can. Good? Last thing about chapter 2 is the properties. So question number 3 will be properties of matrices and scalar multiplications. Scalar multiplications, okay? What is the determinant? What happens if I give you a few problems in exams, like simplify, like 3a plus 3b times something, I multiply by b inverse or something like that. Like simplify this. So a goes with b inverse plus 3b times b inverse, right? Questions like this, like what is the product of A times B inverse? What is it? B inverse times A inverse, right? Just memorize, read lecture notes, basically. Okay? And questions like this from the lectures or the take-home quiz. Yes.
Would B times B inverse become identity?
Yes.
So could you simplify it further, or could it set one?
No, exactly. It would be 3 times identity. Yeah, don't make it 1. It's identity. It's a matrix, not a number. Good. Okay. Anybody has any questions so far? I'm going to move on to chapter 3 then. Okay, chapter 3. I mean, you still go over the lecture notes. I may not remember a lot of important stuff, but this is like the expensive stuff that I want to do. Read lecture notes, practice, all written homework. That's the key. Okay, chapter 3 is all about finding determinants, right? And that's the latest thing we have done so far, so it must be fresh in your memory. Okay, how do I find the determinant? Well, the classic question will be find determinant of A, find determinant of a matrix using cofactor expansion. Using cofactor expansion. And sometimes I might even specify a row I want you to expand along. For example, I give you this matrix again. A equals 3, 2, 1, 0, 1, negative 2, 1, 3, 1. And I tell you, expand along row 2. So you have to pick that row. Okay, what will you do? What's the formula? Good job. So determinant of A, and I recommend that you write down the formula first in terms of the entry place, right? So A21 times C21 plus the second entry in row 2 times its cofactor plus the third entry in this row times the cofactor, right? And I want you to write that question. Oh, because I told you. And in exam, I might say, use row 2. So you have to use row 2. If it mentions it, okay? Otherwise, you pick whatever you want. If the question says expand along row 3, row 4, column 2, column 3, then you must pick that column, okay? For full credit. So read the questions carefully before you attempt the problem. Now, you would still pick row 2 because it has a 0, right? But what I want to emphasize on is write down these entries like this. Why? Because then you know which ones change the sign, right? If you add 2 plus 1, that's the odd entry. So the cofactor will change sign when you write down the minor. But in this case, A21 is just 0, so that becomes 0. A22 is 1. 2 plus 2 is positive, so I can just copy the minor. Minor will be, I have a video on finding determinants if you want to watch. 2, 3 will be negative 2, but that's 2 plus 3 is odd, so I have to multiply by a negative 1 and then copy the minor. Minor will be good, and that's it. So simplify, what do you get? Make sure you put brackets because the too many things are happening here. So just make sure you segregate everything nicely. 9 minus 2, I get 2 plus 2 times 7, I get 16. Yes.
The negative 2 comes in, what is the negative?
2 plus 3 is what? Odd. Every time you have an odd entry, the cofactor changes sign. Right? I mean, read the lecture notes, okay? That's the key. Good? Okay. Finding the determinant is okay. And the another important thing was elementary row operations and determinants. Elementary row operations and determinants. Okay, who's going to tell me which elementary row operation changed my determinant? Yes, at the back. Interchanging will add a negative, right? And I did add 2 more examples in the lecture notes where you can see that the question where I'm multiplying by a scalar. So make sure you try to solve those examples on your own. The ones I have in my lecture notes, okay? They're important. Yes, the most important property is if A is n by n, then determinant of C times A, where C is a scalar, will be Cn times determinant of A. C raised to the power n, because I have n rows. Determinant of A inverse will be 1 over determinant of A, right? What is the determinant of a triangular matrix? Just multiply the diagonal entries. If I give you determinant of A question, if I have determinant of A equals 3, what is determinant of and A is 2 by 2, okay? What is determinant of 3A squared? I have plenty of questions like this for the quiz. How do you solve this? All relevant identities are written here. Okay, who's going to answer? Oh, I only see 2 hands. N is a number of rows. It has to be a square matrix. Oh, come on, I need more hands here. Not the same people. Yes, A exon, yeah. Exactly. So what do? You raise 3 to the power of 2 because A is 2 by 2, and then multiply determinant of A twice, which is coincidentally 3 squared. Right? Just make sure you remember all the rules and identities which are listed in my lecture notes. And what else? Well, this is it. So read the lecture notes. Make sure you can solve all the problems in the written homeworks and quizzes, and you should be good. I'll post this video. Okay, all the best, everybody. I'll see you Tuesday.